Hello, good morning, my dear children. So, as you all know, we were doing the chapter based on light, and we were learning about the topic refraction of light through plane surfaces, isn't it? We have learned refraction through a glass slab and refraction through prism in our previous video lectures. Today we'll be learning about some applications of refraction of light. How are you going to apply refraction of light in our day-to-day activities? Okay, so for this I will be just demonstrating a small talks here through which you will be able to understand the topic that we are going to discuss today. Okay, for that I'm going to take a small container, okay, and I'm going to place a small coin here. So I have a container, and at the bottom of the container I have placed a coin. So you are able to see the things around you when the ray of light after reflecting from that object reaches your eye, isn't it? And that is the time when you are able to see the things around us, and the irregular reflection is the actual cause behind the vision that we have, isn't it? So suppose say a ray of light is coming out through the edge of this container here. So you can see that this is my area of light coming from the coin here. So if I place my eye here, so do you think that I will be able to see the coin here? No, I'll not be able to see the coin right now, because what happens, the ray of light is not reaching, the ray of light which is coming from the coin is not reaching to my eye. So until and unless the ray of light reaches my eye, I will not be able to see the coin which I placed in this can, or you can say container. All right, so now what I do is I fill this container, okay, I fill this container with water. Are you getting my point? So this, okay, let me change the color here, okay. Okay, so now I'm filling this, okay, container, or you can say the can, with the water. So now my coin is inside the water, or you can say under the water, means it is placed inside in a medium which is denser. So if you compare here, you'll see that here I have air and this is my water. So now I have two different medium. So if you compare these two medium, water is denser as compared to the rarer, isn't it? So when the ray of light, okay, okay, now again let me change the color so that you can understand. Okay, so ray of light is coming and striking on this surface. So here I have the surface, and when I draw a normal, you can see that when the ray of light is traveling from denser to the rarer medium, it bends away from the normal, isn't it? So this would be the original path, but it has to bend away from the normal, so it will bend away from the normal, and now it reaches to my eye, isn't it? And if this is my another ray which is normal to the incident, normal to the surface separating the two medium, it passes undeviated, isn't it? So here you see that, okay, you see that the ray is now reaching to my eye, so now I will be able to see the coin. But when I produce this backward here, this will be the place, okay, from where the light will appear to come to my eyes. Okay, so when I view from here, I will see that as if the light is coming from the coin which is placed here. So you can see that at this situation, the coin seems to be raised up. It has like you can say that it has been raised up, okay, माथि उचालेको जस्तै हुन्छ. So here, why is this happening? Because of the refraction of the light. So here you see that the coin has been raised, okay, which was actually here. So this refers to my real depth. Actually coin चाहिँ त्यहाँ छ, but because of the refraction, okay, to me it seems that the coin is placed here, and this height is called the apparent height or the false height. So here you can see I have apparent depth and real depth. So you can see this figure in your book also, okay, in the unit C of the chapter. Okay, so real depth and apparent depth. So whenever you are trying to see some objects under the water, that object which is at the bottom seems to be raised up. Okay, so raised up bhako height lai we call is apparent depth. Okay, and actual depth like bhन्छ real depth. And again, the ratio of real depth to the apparent depth is called the refractive index of this medium. Here I have taken the water, okay, to the other medium, that is air. Alright, so the refractive index of that medium with respect to the air is given by one more relation, that is real, okay, depth divided by apparent depth. So this is the third relation to find the refractive index. In the earlier classes also you have learned to find refractive index from Snell's law. You have learned the refractive index to calculate refractive index with the comparison of speed of light, isn't it? Yes, speed of light. Similarly, you have one more relation here to find the refractive index of the second medium, okay, or the denser medium, okay, by comparing the real depth to the apparent depth. Okay, so I guess you have understood here. Okay, so here now the factors, okay, the factors on which, okay, this shifting, actually it is shifting, isn't it? It was at the bottom, now it has been raised to a certain height. So this shifting, okay, of the object, okay, is this shifting actually depends upon three factors. Okay, the factors are, number one is the refractive index of the medium, okay, number two is the thickness of the denser medium, okay, jati gairo, okay, त्यति नै के हुन्छ shifting, that is the apparent depth के हुँदै जान्छ, घट्दै जान्छ. All right, it appears to be raised up, actually what I mean to say is, okay, and the third one is the wavelength, or you can say the color of the light. Okay, so in these three factors, the shifting, okay, the shifting here, you can see this shift, okay, it was actually here, the coin was here, now it has been shifted to this position. So this shifting, okay, of the object when you are viewing in from the rarer medium, when the object is in the denser medium, okay, it depends upon these three factors. One is the refractive index of the medium, other one is the thickness of the denser medium, and the wavelength, or you can say the color. Okay, so number one is here dependence of the shift on the refractive index. So higher is the refractive index of the medium, more will be the shift. त्यति नै माथि उचालेको जस्तै हुन्छ. Alright, number two is the thickness. More is the thickness, more is the shift. So here you can see that, okay, refractive index, okay, and thickness of the denser medium, thickness of denser medium, they are directly proportional. Okay, they are directly proportional to the shifting. So jati refractive index besi, jati thickness besi of the denser medium, more is the shift, that is the object appears to be raised up. Okay, and the third factor is the wavelength. The shift decreases with the increase in the wavelength of the light that you are using here. So as the wavelength increases, what happens? Shift of the object, shifting of the object, that is the apparent position of the object, decreases. So here refractive index and thickness, okay, they are directly proportional to the shift, okay, whereas wavelength, okay, is inversely proportional to the shift. So wavelength of the light is increased, shift or the apparent position of the object will decrease. All right, so I hope you understood. So now see, I hope you have experienced whenever you put, okay, suppose you have a big tank at home, you take a long stick and try to dip the stick in the water, okay, you will see that the stick appears to be bent. Okay, the stick चाहिँ के भएको जस्तो हुन्छ, bend भएको जस्तो, you will see that, you will like it will appear to bend. So that is again why, because of the refraction of light. You can see this, okay, you can practically see this when you take a long stick and insert that long stick in a tank which contains water. So when you view from the top, you will see that as if the stick has been bent. Why? Because of the apparent position of the stick. Stick चाहिँ के भन्छ, अलिकति माथि उचालेको जस्तै हुन्छ because of the refraction, because the light now comes from the stick which is in the denser medium towards your eye, that is which is in the rarer medium. All right, so this question has come in the ICSE in the previous year, so you please go through the shifting, okay, or the apparent bending of the stick, okay, under the water, which is in the book topic number 4.11. all right, then you can have some consequences or the results, okay, because of the refraction of light in our daily life. That is the things that you see in your day-to-day life, that is because or due to the refraction of light. All right, so the number one is the appearing or the appearance of twinkling of light in the night. When the sky is clear, weather is fine, you can see that the sky is in this the stars in the sky twinkle, isn't it? Actually, stars do not twinkle, they appear to twinkle. Again, why? Because of the refraction of light. All right, similarly you can see the sunrise, okay, before actually the sun comes above the horizon. Okay, घाम निस्किनु भन्दा पहिला तिमीले देख्छौ घाम. Again, why? Because of the refraction of light. Similarly, in the evening when the sun is setting down, when even you will be able to see the sun even after the sun goes below the horizon, down the horizon. Even after the sun has gone below the horizon, you are able to see the sun, again because of the refraction of light. Okay, and you can I guess you have experienced this when you have a thick glass and you place thick glass on a thing material which writing material, okay, or on a printed book. You'll see that the letters of the letters has been raised up. Okay, that is again because of the refraction of light. So similarly, you can see many other consequences, okay, examples which you can find in our day-to-day life, which is due to the refraction of light. So these consequences, okay, or the results, okay, which are because of the refraction of light, is very important for your ICSE. Okay, if you want to see it as per your point of examination or point of ICSE examination, these consequences are very important, because every year question, one question which carries a minimum of 2 marks or maximum of 4 marks comes in your ICSE from this particular section, that is consequences of refraction of light. All right, okay, now we are moving to the new topic, another topic, and the topic is like this. See, suppose this is my surface which is separating my, okay, a denser medium. So here I have denser medium to the rarer medium. Are you getting my point? Okay, so when a ray of light is passing from the denser medium to the rarer medium, what happens? It bends away from the normal. So this is my angle of, this is my angle of incidence, okay, and this is my angle of refraction. So here you see that the refracted ray bends away from the normal, isn't it? Yes. Now with this concept, okay, with the same concept, I am going to change few things here, and as I change, you try to figure out, okay, what is actually happening here. All right, okay, now let me change the color of my pen. So now this is my angle, incident ray, means this is my angle of incidence. Now I have increased the angle of incidence, so this refracted ray has to bend more away from the normal, isn't it? Ajay yo away from the normal janu paryo, so it will bend in this way, isn't it? So as I increase the angle of incidence, okay, so I have further increased the angle of incidence, what happens? My angle of refraction also gets increased. So a situation will come when the angle of incidence in the denser medium, okay, for this angle of refraction in the rarer medium becomes 90 degree. So जति मैले यहाँ angle of incidence increase गर्दैछु उता angle of refraction पनि के हुँदैछ बढ्दैछ, isn't it? So a situation will come here, okay, so a situation will come here when, okay, this is my normal, for example, when for my particular angle of incidence, okay, angle of refraction becomes 90 degree. त्यति बेला चाहिँ यो angle of incidence लाई चाहिँ we call it as critical angle. What do we call it? Critical angle. Now you need to understand here. Now what is critical angle? Critical angle is angle of incidence. Angle of incidence नै हो. Critical angle पनि angle of incidence नै हो. But it is unique in itself. It is unique. त्यही भएर चाहिँ यसलाई एउटा पर्टिकुलर नाम दिएको छ. What is that? That is critical angle. So we call it as critical angle. Why? Because for this particular angle of incidence, angle of refraction in the rarer medium is 90 degree. भन्नुको मतलब चाहिँ the refracted ray passes through the surface which is separating the two media. See, it's very simple, very logical, okay, very easy to understand. So critical, let me repeat it again. Critical angle is the angle of incidence in the denser medium for which the angle of refraction in the denser medium is 90 degree. I hope you have understood now. Yes. So here in this activity you saw that as I was increasing the angle of incidence, angle of refraction was also increasing. So a situation comes when the angle of incidence in the denser medium, for this particular angle of incidence, the angle of refraction in the denser medium, rarer medium becomes 90 degree. त्यति बेला चाहिँ यो angle of incidence लाई के भन्छ? Critical angle. So we call it as critical angle. Are you getting my point? What do you call it as? Critical angle. Did you understand here? Is it okay? Alright, now let's go to the next page here. So here you see that my surface, okay, this is my surface. Suppose let me name it as M dash. This is the surface which is separating the two media. Suppose say this is my rarer medium, this is my denser medium, this is my point of incidence, okay, this is my incident ray, this is my normal, and this is my I, and here in the subscript I have C, means this is my angle of critical angle. Angle of incidence नै हो, तर यो critical C लेखेकोले चाहिँ भयो critical angle, which means that my angle of refraction in the rarer medium will be 90 degree, isn't it? Yes. So here now if I try to find the refractive index, now you know refractive index from the Snell's law, it is sine I by sine R, hasn't it? But at this situation, at this particular point, you see that here, okay, refractive index of the denser medium with respect to the rarer medium is sine I. Now what is I here? C, capital letter C. Capital letter C indicates or represents critical angle, okay, divided by sine R is 90 degree here, isn't it? This is my 90 degree. Yes, and you know sine of 90 degree is 1, isn't it? Yes. So refractive index of denser medium to the rarer medium is given like this: sine of critical angle. Are you getting my point? Yes. Or you can see that if you know the value of critical angle for the given pair of media. Okay, if you know the critical angle, you can easily put the value here and easily find the value of sine of that particular angle, and you can get the refractive index of the denser medium with respect to the rarer medium. All right, so this is our critical angle. So the first assignment for today is what do you mean by critical angle? All right, and the relation between the refractive index and the critical angle. This is your assignment number 2. Okay, what is the relationship between the critical angle and the refractive index? All right, so that is your another question or assignment. All right, yes. Now, okay, now let us continue the same activity. Okay, now we are continuing the same activity here. And what is that? See, in the beginning, what did I do? I was increasing the angle of incidence. Now again I will increase the angle of incidence. So this is my surface which is separating the two mediums. Okay, two media. Here I have the denser and here I have the rarer medium, and this is my normal and this is my point of incidence. All right, so now this is my angle of incident ray, and this is my critical angle. All right, and when this is, if that is my critical angle, okay, then at that position this will be my refracted ray. That would be my refracted ray, and this would be my angle of refraction, isn't it? Now what I will do is that I will further increase the angle of incidence. Okay, angle of incidence लाई चाहिँ मैले अझै के गर्दैछु, बढाउँदैछु. I am making it more than critical angle. यति बेला चाहिँ what happens, this refracted ray, now since the incident ray is traveling from denser to the rarer medium, so obviously it has to bend more away from the normal. अझै bend हुनु पर्यो, isn't it? So here when I increase my angle of incidence, okay, make my angle of incidence greater than the critical angle, at this point of time what happens, the refracted ray bounces or comes back to the same medium. This is what we call total internal reflection. So what we call it as total internal reflection. So here you can see that the incident ray and the refracted ray, now this is not reflected ray, this is refracted ray. Okay, here it seems as if the reflection is occurring, but actually this is refracted ray only, because the ray is traveling from denser to rarer medium. There is a change in the medium. The medium is changing, isn't it? Yes. Okay, so you see that what is happening here? The ray is coming back to the same medium, so it appears as if reflection is occurring here. Okay, but that is not the actual point here. Actually refraction नै भएको छ. But since you have here, you have increased the angle of incidence more than the critical angle, त्यसले कारणले गर्दाखेरि चाहिँ the ray comes back to the same medium, and we call it as total internal reflection. Okay, clear? What we call it as total internal reflection. So the third assignment for today is, what do you mean by total internal reflection? So you can write the answer as, when a ray of light is traveling from denser medium to the rarer medium, or you can say that when a ray of light, okay, is in the traveling from the denser medium, okay, which is incident at the surface separating the two media, okay, at an angle greater than the critical angle, then what happens, the ray is totally reflected back in the denser medium. This phenomenon is called as total internal reflection. So this is your third assignment for today. Okay, now you will see what are the conditions, okay, conditions which are required or essential for the total internal reflection. So there are two necessary conditions which you require or which you have to fulfill to observe or to have this total internal reflection. Okay, total internal reflection. And what are they? Number one is the ray of light, that is the incident ray, or you can say that the ray of light should always travel from denser to rarer medium. Very important point to be noted here. Total internal reflection occur garauनको लागि चाहिँ you must have the ray of light which is traveling from the denser medium to the rarer medium. Alright, kina? Why? Because the ray bends away from the normal only when the ray of light is traveling from the denser to the rarer medium, isn't it? Now, if the ray of light travels from rarer medium to the denser medium, it will bend towards the normal, isn't it? Towards the normal. Yes? If this was rarer medium and if this was denser medium, the ray of light would travel towards the normal. यता पो छड्किँदै जान्थ्यो, isn't it? Yes. So to observe total internal reflection, the first condition that you must fulfill is the ray of light should travel from denser to the rarer medium. All right. Now the second condition, I guess you have already noticed. Critical angle भन्दा चाहिँ incident angle of that particular ray should be greater. Okay, the angle of incidence must be greater than the critical angle for the given pair of media to have total internal reflection. So this is your second essential condition which you must fulfill to have total internal reflection. Okay, so the fourth assignment for you all for today is about the conditions. So what are the conditions, essential conditions required for total internal reflection? The answer would be there are two essential conditions which are required to have total internal reflection. Number one, the light must travel from denser to rarer medium. Number two, the angle of incidence should be greater than the critical angle for the given pair of media. So that would be your answer. All right, is that understood? Is it understood? Okay, so this is it for today. Now, okay, before I end, okay, here, why we call it as total? Why do we call it as total? See, whenever a normal reflection occurs, suppose this is your mirror, okay, this is your mirror, and this is your incident ray. It is striking here and it bounces back, which is called as reflected ray, and this whole phenomenon is called as reflection. So whenever reflection, normal reflection occurs, some point of energy is lost here. Either it is absorbed by the medium, okay, or it is scattered away, isn't it? So there is a little amount of energy which is lost in the phenomenon here, in the process of reflection, you can say. But when you are having total internal reflection, because of the refraction here, what happens? Whatever was the intensity or the magnitude of this light which was incident here, the same amount of light is get what? Reflected. Nothing is lost here. So that is why we call it as total. जति थियो त्यति नै फर्किन्छ. So that is why we call it as total internal reflection. All right, is that understood? Okay, so now along with this video lecture, okay, I will be sharing you one more link, okay, where you will see the consequences, or you can say the results of total internal reflection which we see in our day-to-day life. Okay, please go through that also. All right, so that's all for today. Thank you.